Okay, this is a presentation about graph transformations, reflection, rotation, translation, and enlargement. So, starting off with a basic shape, here is a reflection being done. First of all, the vertical line M is the mirror line that we're going to reflect it in. And then what we need to do is measure up to the mirror line from the shape, and then over the other side the same distance again. Now these lines that we're drawing across are at 90 degrees to the mirror line. So we're drawing guidelines at 90 degrees to the mirror line from each point, and then measuring the same distance the other side to find out where our new point goes. So that's reflection. Here's another example. This time it's a little bit harder because the mirror line is a diagonal line, but still we just measure 90 degrees. That's supposed to be 90 degrees. It might not look it if this is being viewed in widescreen, but 90 degrees over the other side to find out where the shape goes. Now, rotation. Well, a rotation has various aspects to it. It has a center of rotation, and then it's clockwise or anti-clockwise, and then a number of degrees. So, for example, if the point marked here is the center of rotation, we need to draw a line to each point, measure the number of degrees that we're rotating it using a compass. So I've put the center of my compass at the center of rotation, and then I've drawn a curve, an arc from the point clockwise, because we're doing a clockwise rotation. And then I've drawn it until it's 90 degrees to find where the new point goes. Again, if this is being viewed in widescreen, it might look a bit more than 90 degrees, but not everybody has the same screen size. So that's where that point rotates to, and then we do the same with each other point. So from the center of rotation, 90-degree turn to find out where each new point goes, and then join them up to find the new shape. It doesn't always have to be 90 degrees, doesn't always have to be clockwise. It would be specified in the question. Right, translation is just shifting a shape up, down, left or right. So translate this shape by 5 minus 3. The first number, the top number, is the left-right number, so that means it's going to go 5 forward, 5 to the right, and then the minus 3, well, the second number is the up-down number, so minus 3 means that it's going to go 3 down. So from where it was, each point goes 1, 2, 3, 4, 5 across, and 1, 2, 3 down. Like so. Enlargement. Well, these are two similar shapes. It's the same picture, but one is an enlargement of the other. And if I join up corresponding points, like the top of his head, or the underneath his arm, or where's that, from his thumb, for example, from the top of the football and the bottom of his boot to the bottom of the football, all of those join up at a single point. That point is called the center of enlargement. So, in an exam question, you might be asked to enlarge a particular shape with a particular center of enlargement. So, for example, if I want to enlarge this triangle with the center of enlargement to 1 as marked, then I draw lines from the center of enlargement to the shape and beyond. Now I've drawn the line twice as far from the center of enlargement as the original shape because I want a scale factor 2 enlargement, and there it is. So because I wanted it scale factor 2, that meant that every point had to be twice as far away from the center of enlargement as it was in the original. And there's another example. It's probably a little bit small to read on the screen, but it says scale factor half enlargement. So every point is half as far away from the original, from the center of enlargement, as the original shape was. And you can even have a negative scale factor if everything's the same distance away from the center of enlargement as the original shape, but it's over the other side, so that the shape inverts, flips over, then that's a negative scale factor. So what we have here is a scale factor -1 enlargement. And we call it an enlargement every time, even though sometimes the shape gets smaller, sometimes it's the same size but the other side. All of them are called enlargements, even though the shape doesn't always get larger. And that's the end of graph transformations.